Well, hey, I got to give this problem another try. This is one of the examples from the Applied Optimization packet 4.7. When I did this problem originally, I failed to take into account that there's a maintenance cost for the units. So my original do of this problem is wrong. It was right if maintenance cost nothing, but I completely neglected that. So I'm going to redo this. I'm going to redo this problem and hopefully get it right this time. Let's kind of start this problem kind of as we did last time. Let's let U equal number of units rented out. And let's let R equal the rent per unit. We seek to maximize omega, which is the profit, which is the number of units that I'm rented out times the rent per unit. But then there's also the number of units that I rent out times 200. That's the maintenance cost. I completely failed to do that last time, and that's unfortunate. So we could factor out the U from both of those if we want. So as a reminder, we really want to get a single variable for our omega, and the path forward is with U equals U of R, because we were given that all units are rented out at $2,000 a month, and for every 100 increase in rent, demand decreases. I think the way to think about that, again, is going to be the exact same calculation in terms of getting U equals U of R. Let's see here. I'm going to use point slope form to get this, so that U minus, let's see here, U minus 30 is equal to minus 100. I think that's 1 over 100. Let's see here. I'm getting ahead of myself. As I'm trying to just remember what I did almost a week ago when I wrote this. Okay, so let's see here. So 30 units rented out when the rent is $2,000 a month. Okay. So when the rent is $2,000 a month, I get 30. So if I do that, then I just need to figure out what's that decrease, which is, let's see here, minus 1 over 100. Yep. I like this. This is good. Okay. So again, I'm going down 1 unit rented for every $100 increase. And right here, essentially, this is a delta R calculation, right? Because I have R, the rent, minus 2,000. This essentially is the difference in excess of $2,000 for each unit. This is exactly the same as it was last time. So U is equal to minus 1 over 100 times R minus 2,000 plus 30. And so we're going to take that expression for U, and I'm going to put it in for U right there so that I have this as a single variable. Maybe we want to simplify the right-hand side here of this linear relationship, and that would be fine. Let's go ahead and do that. U equals, in blue, because it was already blue, U equals minus 1 over 100 R plus 20 plus 30. And the R rent has to be at least $2,000. So this is equal to minus 1 over 100 times R plus 50. Seems reasonable. Yeah, that checks out. Okay, so let's plug that into omega. Omega equals minus 1 over 100 R plus 50 times R minus 200. And again, it's this minus 200 that I forgot in my initial pass on this problem. And for that, I apologize. But it's going to work out and be okay. Let's go ahead and do the distribution on this problem. So that omega is equal to minus 1 over 100 R squared plus 50R minus plus 2R. That came from this 200 and this 100 here are going to cancel. I've got, right, two minus signs right there, which are going to turn into that plus. Then I have minus 50 times 200. And 50 times 200 is like 100 times 100. That's 1, 2, 3, 4, $10,000. Okay. Right, because it's 10 groups of 1,000. Yep, okay, great. Okay, so let's go ahead and do one level of combination of things. Minus over 100, R squared, plus 52R minus 10K. That's my objective function. And now we're going to do optimization on it. So that's going to be to take omega prime and set it equal to 0. Omega prime is equal to minus 1 over 50R plus 52. The 10,000 goes away because it's a constant. And I want to set that equal to 0 to find the crip points. We'll move that 1 over 50, 1 over 50R equals 52. R equals 52 times 50. And can I do that in my head? Sounds unlikely, but that's okay because I happen to have a TI-84 at my desk. So I'm going to go 52 times 50. And let's see here. Did I do something? That's okay. Okay, so this is 52 times 50 is 2,600. Great. Okay. So 2,600. That's my crip point. Okay. So in terms of the real number line on which my rent lives, the minimum number of rent that I have is 2,000. We found a critical point at 2,600, and then the maximum allowable rent that I should probably have. Let's determine what that would be. I think we should consider this. When will eventually the number of units become 0? That's if my rent is $3,000 in excess of the base rent, because then it would lose all 30 units. And so that's going to be 5,000 max rent because U of 5,000 equals 0. Okay, so let's build a little table of rents and profits. My rent is 2,000, my rent is 2,600, or my rent is 5,000. What we're going to do is we're going to take each of those values and we're going to plug them into our objective function. That one might be, like choose one of them. You could use like the ANDS trick to evaluate these things, whatever it happens to be. I'm going to use the ants trick right now. And let's see here. No. Skip. Why would I ever give you anything? Okay, so my function is, or my value is 2,000. I'm going to use the ants trick. So I'm going to go minus 1, I better use parens to enter my value, minus 1 over 100 times answer plus 50 times answer, which is R, minus 200. Okay, so all I did there was enter that in the formula over here, and so now I'm going to push enter, and I'm going to get $54,000. Cool, that seems good. That seems better than 0. If I do that, I'm going to go 2,600, second entry, enter. Ooh, 57,600. That's better. I like that. So far, that's our candidate. 5,000, enter, second entry. This is going to be 0 because all the units were rented out. So don't do that. So our max profit is at rent equal R equal 2,600. I don't remember what answer I got last time, but I'm sure it was wrong. Maybe slightly different from this. So we actually took into account then the loss due to maintenance, and that does have an effect. So I'll say thank you so much for watching this correction. I really appreciate it, and we'll see you again next time. Bye.